Well, appears to be live. Volume doesn't seem good enough, but it'll have to do, I suppose. See if it sounds okay on the computer. Should start soon. Come on. I just have to do this test. I have the sound off. I don't hear me. Yep, not working. Whoa. This test. I have the sound off. Okay, that's working now. Okay. Anyway, sorry for the crappy beginning. But the whole thing might be crap because I really don't have a set agenda. So I was, last video I made, I guess, was a response to Hoffaday on the two slit stuff. And so I have been thinking about different ways to try to filter light. And yeah, by my old theory, it was possible because the light that went through the center was being unfiddled with. But the field line theory kind of wrecks that in terms of being able to avoid diffraction and to filter. Like I was thinking, if you put a small opening ahead of a small opening instead of a small opening, that you would eventually end up with filtered light, but you really can't filter it. You always end up with a diffraction at the end, even if you got undiffracted light reaching the third slit. But it would be interesting to, I suppose, well, I guess it wouldn't, because you already know how much light's going to be diffracted, so you already know how much it'll diminish as it passes through. So anyway, but the other side to his the lecture guide that he pointed to was a bunch of the gravitational lensing evidence, and most of them don't have anything to do with light. They have to do with radio telescopes sending signals through in the proximity of the sun, and the fact that there's a delay in how long it takes the signal to come back, which implies that it's bent, and that's why it takes longer. Okay. The path has been bent. But the problem with all of these experiments is this, it's a problem that's systemic sort of to the solar lensing, is you kind of have to do the lensing far enough from the sun to avoid the atmosphere of the sun, which causes scatter and diffraction. So his evidence kind of doesn't mean anything unless you can filter it for diffraction, which means if the signal is substantially weaker, then obviously the signal was degraded because it traveled through a medium. And so obviously the obvious argument is that you're just measuring diffraction, then you're not measuring gravitational lensing. So we're just back to the two slit problem of being able to distinguish between when a photon moves because it's being moved by a force, and when a photon moves because it's interacting with matter, electrons and protons and neutrons. So I would argue that the latter is the problem, and that any solar lensing that involves a degrade of the signal would indicate that the light didn't travel through empty space and wasn't necessarily moved by gravity, but was moved by the dirt surrounding the gravitational body. And so, yeah, I don't know exactly where Einstein's equations, how close the light has to travel to the surface of the sun by Einstein's equations. I would imagine the argument is the lensing is pretty far from the corona of the sun because it has to be optically observable in an eclipse. In an eclipse, isn't blacking out all the light from the sun. Obviously, it's just most all of the light, and you're still left with that the scatter light that's radiating from the sun's corona, and but it has to be strong enough where you can actually see stars behind the sun. So it has to be far enough away from that the noisy parts of the sun, the atmospheric part of the sun, to cause the lensing. So I think I could argue that the experiments that have been done with radio waves and other forms of radiation are flawed if we don't have the information about how degraded the signal was. Because if the signal was highly degraded, that would mean it went too close to the sun and therefore was diffracted by the atmospherics of the sun. So for those who are interested, I know that you have to kind of have a certain level of understanding about what I'm talking about to understand what I'm talking about. So sorry about that. So the other subject, let me think, there's another one that was important. Yeah, no, the like I said, the lecture did point to a couple of really poor galactic images, just frankly absolutely useless. They're so bad as evidence of anything, and they're still not explaining, except for the, well, look, this proves the existence of dark matter. So I mean, they're using the impossibility of the gravity equations, the fact that, well, there couldn't possibly be enough gravity there, so I guess dark matter must really exist because that's obviously lensing. So they're using lensing to verify lensing, in a sense. It's just it's such a, they're using lensing to validate dark matter, which in turn validates lensing. So it's circular evidence. It's such a cheat that it doesn't have any use as an argument. So I didn't make any videos on that, just because I had time to do any real research on the different satellites and exactly finding out how weak the signals were and whether they had, I mean, the guy actually mentioned scatter and diffraction as possible explanations, and that they had some mathematics or something else that they used to presumptively eliminate that as the possible cause. But I'm suspect of obviously the rationale, because it probably does involve some presumptions that are not valid presumptions or assumptions, like dark matter. Yeah, so this one, the solar lensing is always going to be a hard argument, even if you find it, to demonstrate that it isn't an atmospheric effect. Because I guess I would argue that all the electrons around the sun would certainly be lined up to the gravity of the sun or the magnetic field of the sun, and that they're going to have a tendency to do exactly what happens in the two-slit experiment, which is they're going to move in a very specific direction. So the diffraction is going to be very specific in its directionality. It's not going to be scatter, it's going to be diffraction. Yes. Okay, so yeah, so the other subject, so the two-slit experiment, let's see if I have the link here. I don't know if I have it. Yeah, it's relatively available, so maybe we'll screen share it.
The dark lines.
Okay, so I was thinking about this my argument that the single slit and two slit math basically creates the possibility of almost an infinite pattern being created in terms of its width. I mean, it could go very, very far, and that there really hasn't been any experiments I've seen to establish the existence of that pattern in the places where it would be detectable over a long time exposure. So it should still be there. So by their explanation of the wave interference, the pattern where it diminishes at the edges, the periphery, it should actually still be there. It's just not visible. And that if you did a time exposure, it should be visible. And I haven't seen verification of that anywhere. What the hell happened to? This is weird. Well, anyway, so I'll do a screen share, I suppose. Even though this, what happened to the other window? Doesn't seem right for some reason. They should be on top of each other. But anyway, not going to worry about it. So I'll do a screen share. And see, it's not showing up. That is strange. All right, well, there, that's it. Okay, sorry. I'm old and technology is irritating. Okay, so you should be seeing that. I guess I better make sure you're seeing that. Yes, you're seeing that. Okay. So what I was thinking about, so I don't know if you can see this mouth. You can sort of see where the end is here, where it disappears. And, you know, there's a little sense that it goes a little bit further than what you can see. And so if you could up the brightness, you'd see there would be an edge. But I'm just saying that theoretically out in this dark space, there still should be a pattern. It should just be faint. But by my theory, these little dots sort of represent the field lines, and that it would always be in a confined space. There would be a limited space that the pattern would exist in. And so I'm going to play this, and as you see it change, as you see these patterns change, I would argue that they're staying within that confined space. That it doesn't spread wider. It stays within this circle, or whatever you want to call it, this size, and it doesn't get any bigger than this size. And I think that's a curious fact.
The diffraction which is taking
So
over.
you see, it looks bigger, but
Right
it's still fundamentally
wider,
staying.
and I make the slit narrower.
It's staying within this basic size. Well, it's a little bigger there. Okay, so if I leave the mouse, well, I can't leave the mouse, but I can put my finger on it. So I'm going to put my finger on that last little dot where the mouse was, and then I'll go back. So we'll see if this is at all relevant. Okay, and then we'll start it from here.
Slit is now very wide, and so the size of that slit that you see there, the size of the bright spot, is now entirely dictated
put the mouse
by
back.
the divergence of my laser beam.
All right, we'll
The
get to it.
diffraction
Hurry up.
width is negligibly small because A is very large.
Oh, my mouse disappeared.
Now what?
Stay
Now
there.
I'm going to tighten, make A smaller
So let's see how wide it
Doing that now.
goes. If it goes as wide as
Making
the
it smaller.
mouse.
and smaller. The diffraction which is still negligible, making it smaller.
See.
I'm beginning to see the dark line. The diffraction which is taking over. Look at the center.
Yeah, see, so it's
Right there.
it's the same size.
Getting wider.
Whoops. And there's
Getting
the
wider.
mouse.
And I make the slit narrower. It's getting wider. It's getting wider.
The,
And look
the
how
cutoff
beautiful you
point
see
is in the
these
same
structured
place.
interferences.
Okay.
The light plus light gives.
Yeah, that's right. Light plus light gives darkness. But anyway, so it is, even though it looks substantially different, it's pretty close proportionally. Within 80%, it stays within the same size, which is kind of curious because you would think if it's spreading that the intensity would spread out further here, because these bars are supposed to be a certain percentage of this center bar. So if this is 4%, the second maximum, this one's 1.6%, as they're supposed to be, that percentage should stay the same no matter what size this thing spreads to. So I guess that's something to validate, is whether that percentage stays the same, the 4.8%, of the central, if that's a standard for no matter how wide this slit is, that percentage is supposed to stay the same. Because if that percentage is supposed to stay the same, you could theorize that why isn't this pattern visible a lot further out? Because you're seeing much higher percentage spots of light, so they should be more visible, technically. I think that's what I'm saying. I think that's correct. So anyway, but that's a curious, something to think about anyway. I haven't figured out exactly what it means, but yeah, I just thought it was curious. When I noticed that. So it's something to do some work on. I mean, that might be a point where I could do that might be a place where there might be a proof, is in the fact that if the pattern doesn't go infinitely, or theoretically infinitely, like I said, the amount of light gets so small by the math that you're talking about, probably at, if you go 3 feet away from the center maxima at, say, 10 meters, or say 4 feet away, you might be as low as, 1 in 1,000 photons would end up out there. Some kind of, very small percentage, 0.01% or something, But anyway, found it curious. I did. And such. And so, yeah, so I did do a little fiddling with my software program to mimic the function of the electrons. But I think I'm just gonna have to rewrite it. I mean, not totally rewrite it, but I'm gonna have another theory for its construction. Because the geometry I'm using now is, I'm trying to mimic the idea of the spherical pressure from all directions, and obviously that's really hard to do. Maybe it's not obvious to you, but it's not. It's easy to do geometry, up, down, right, left. It's very hard to do angle geometry. That requires a whole more complex set of mathematics to get that right. And so I kind of want to keep it up, down, left, right, just break it down into 2 dimensions and keep it simple. But it does get complicated in trying to create a program that, how to put it, the force isn't, there's no way to write a program that allows you to have pressure coming down and pressure coming from the sides and have the line by line do that in some sort of, do it in a progressive manner. You have to do it from an inside out manner. So you're automatically stuck with a conflict between the idea of, the closing of the box top to bottom, and the idea that the things are going to not go necessarily top to bottom, up or down, or left or right. That's not even exactly what I'm trying to get to, but it's just, yeah, well, I'm just saying that it's more complicated than I had hoped. In terms of, it might be very simple. I just have to start from just the center cell. So I first just have to make the electron and then create a synthetic pressure that holds it together. And then I'm going to have to find some way to monitor the balance of that pressure so that the electron can move through the pressure. So the pressure has to be able to yield to the acceleration of the electron. And that's the part where, like I said, it gets a little bit, once you have it, it'll be really nice. I mean, once you got the working model, it's just finding a programming regime or algorithm that mimics that. So anyway, not your problem. I'm just saying that's it's kind of just a. I was hoping I could do it in a crude way, and I just had to do it a little bit more sophisticated than I was hoping I could get away with. And so yeah, it's just more work. I have to think, and I have to fail and trial and error and all that. I have to invest time. It's just I'm so time exhausted. I've been making a lot of philosophy videos lately, and that requires that you watch videos that are really tedious and irritating. So, it slows you down a little bit. Not too much of, I haven't gotten too many comments that are of much use. But some funny guy did, I just think sometimes people are very funny. So his name is Man Cave Dweller 1. So man caves are supposed to be like, men who really aren't doing the domestic life thing. And so it's just so funny. I was listening to what you had to say, but unfortunately had to stop early because of all the swearing. That was the video about the stack exchange that, deleted my post. Kids around. And I'll make a point not to listen to any more of your videos. Sorry, I just don't agree with that unnecessary crap. So, it's just so anti-man cave dweller. The whole point of having a man cave is to get away with, to get away from the political correct. It hurt the woman's feelings, or, it's a swear word. And then kids. Kids in your man cave. That should be, isn't that like a rule of a man cave that you wouldn't let a kid in one ever? I just found that kind of hysterically hypocritical, or whatever the right word is. So anyway, let's see. The superior mind comment. I know I've read it before, but I just don't like this first line. We know that photons must interact with the fields at the surface. Fields, a field that can't affect, well, a field, I guess if it's a field with electrons in it, then what you're saying is okay. So I guess sometimes the word field and the word force can get blended into each other, and I guess that's the dangerous area. You always have to be clear that it's one or the other. Hey, Wayward Horizon guy, he did something quite bizarre, I have to say. And if you want to, you don't have to, something happens and you got to undo what you did. It's okay. You can, it's okay. It's very nice of you. You really don't have to do that, though. You don't have to, you really don't have to do it that way. You can just, say, hey, Gary, my bad, blah, blah, blah. But anyway, I appreciate the gesture and all that shit. And hopefully, hopefully there won't be a round 14 or anything. So anyway, upload frequency has been pretty high. I wonder what that even means. Yeah, I don't know. Upload frequency. Oh yes, a lot of videos. Yeah, unfortunately, long videos too. So that's not too good. I try not to dump 2 hours of shit a day on people. I have a pretty high opinion of myself, but, thinking that people want to watch a full-length movie of Inmendum talking, oof, that's a little too much. But I was just curious. Anaconabot had been on vacation, and he came back at the same time, fake Sagan shows up. And, now I have always a little bit of crap between me and Puro. So it was kind of a weird circumstance. Very strange. Yeah. But wayward guys, you want to talk on Skype sometime, if you want to, if you have a time in particular or something, blah 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 blah. Um, so well, where else am I? Yeah, so I'm a little disappointed I haven't gotten as much done as I wanted to, because I really like the new model of the Electron. I like the idea that I think I have down the conversion, what quanta are doing. When they're, like I said, this whole new model of the Electron is it's, yeah, I mean, my icon is this roundy thing, and what it's really doing is this back and forth thing. So the Electron is basically, so now the new model would be like a porcupine thing, with little line radians. It'd just be a bunch of radians. And what they're basically doing is they head for the surface, they hit the pressure reverses them, they reverse at the ends, and it's just I don't know how to describe that exactly, but yeah. So it's like a pen. There's a collection of them all going the same way with the same polarization, and that thing just keeps going back and forth inside the Electron, and they're all just trapped doing that in this pressure field, and so they can't escape until one hits this end and it pops out this other end, and then it might escape, but that's the only way they can escape the pressure, is something has to be added. But if it's not added in just the right way, it won't escape. It'll just inch the thing forward, and it'll just keep doing this in a forward direction. So it'll go back a little forward, one step back, two steps forward, one step back, two steps forward, that kind of thing. Herky jerky. And that's why electrons move so much slower than photons in most circumstances. And the only time we think they move faster is probably in a circumstance where the electrons don't actually move. They just transmit the photons from one electron to the next electron. They're just conveying them. I think you already have me on Skype, I think. I mean, I might have deleted you or something in the crisis period, but I usually don't bother. But yeah, well, whatever. I'm just saying, yeah. Blah 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 blah. Appreciate it. It was an unnecessary gesture, whatever whatever. Just go out to the store and find a greeting card that says something like "Thank you." Just pretend I bought it and sent it to you. Yeah, something like that. Anyway, so what else am I working on? Yeah, I still want to do some two slit experiments. I got this there, with the mirror. I still got it sitting here, and I have quite a few laser pointers, and just have to wire them up to a single power supply. But I'd like to try different beams of light and see what happens too. What else did I want to do? Oh, the electric thing. Yeah, I definitely want to try that. So I'm going to try wires, with a distance between them, and then I'll put a charge on them and see if that changes the pattern any. Yeah, I haven't seen any experiments that explicitly do that. So, but yeah, I need to find a hard piece of gotcha. I need a gotcha piece of evidence where it's just. I think their own math. I could get them on their own math because their own math doesn't fit the patterns accurately. Um, but and certainly Huygens is so nonsensical in no sense. I mean, the idea of a flat wave going in and it somehow creates bulged waves that create new flat waves ahead of it. So I mean, it just doesn't make much sense for you to think that okay, you have a flat line moving, and the argument is there's a bunch of little bulges popping out of that flat line that are creating the next flat line. Well, just logically, the little bulges are all not going to create a perfectly flat line. And so then they have to make the little waves almost infinite to create the flat line, right? So the only way you could make a flat line is to have an infinite number of those little waves. And, you know, that's already getting as an abstraction kind of silly as a representation of anything real. Because you're like, no, reality doesn't do that. Really doesn't. Um, and it's just such a perverse Frankenstein kind of way to turn something like light into a wave in a medium. And like I said, we know why waves bulge in mediums is because the tension of the fluid. And if you use fluids that don't have tension, you don't end up with bulged waves and you won't get an interference pattern. So if you use a very viscous, well, I guess the opposite of viscous, unviscous fluid, I think they've done it with mercury or something. I'm not sure. But I mean, some of those kinds of liquids don't transmit waves well at all. But that's the catch. You can't transmit a wave in a medium that doesn't have adhesion. And you can't help but have friction if you do have adhesion. So if the substance has a bonding agent, a glue in it, then it's obviously the glue is going to get stretched when you push it through any kind of slit or anything. And it seems kind of bizarre to turn something that we know to be so frictionless in its function, light, and now to turn it into something so um, like there's some kind of friction, like somehow the light is having a friction problem as it goes through the slit. That's why it's getting bent. It's because it's slowing down at its edges, and we know that's not happening. So it just seems like such a contrivance. But me saying it's a contrivance is, I got to do better than that. I'm just saying I think somebody who really looks at it, they can kind of see how this just, like the dark matter thing, it just seems like they're engineering a solution to a mathematical problem rather than figuring out the real cause. They're just engineering they're forcing a square peg to go into the round hole. Yeah, that's it. All right, so it covers that. Oh yeah, let's see if Maxim, who the hell is that? Nobody could have a name like that. It's not possible. Let's see, videos with your critics of late. I don't know who the hell you are. I like when people ask for a Skype and they, like, I don't know who the fuck you are. What do you want from me? Okay, you like something. Well, that doesn't, I guess there's no harm, I mean, most people don't call you randomly, but it is just kind of weird that somebody just says, yeah, I've been watching your videos for a long time. So somehow I should, click, oh yeah, okay, go ahead. Yeah. Give him full access to my life. Anyway. What else is news? Yeah, where's the Australian guy? I can't even find his name on here. Where the hell is he? No, doesn't matter. I guess if he contacts you, we'll pop up on the list here. I guess I should turn the sound on, maybe. Yeah, that's a good idea. All this technology. I have noticed that, I'm using this Windows 10 thing, and it's just kind of funny because there's a couple of web pages I went to that don't work in Firefox on Windows 10. It's like, I don't know whether they're running some kind of app or some kind of background thing, but it is kind of funny that if I run it on the XP machine, I can view the website. Doesn't work great, but it works. But it just kind of totally fails. They have a bunch of crap. They have a bunch of Facebook links and other kinds of bullshit. So it's no doubt one of those add-on things that's fucking the page up. But it's just kind of funny that the more modern operating system is less equipped to deal with, to present me the internet in viewable form. But I have seen that a lot. There are a lot of pages are just, you can't even view them. I mean, they have the pop-ups or they have some other kind of crap, and the stuff crashes, and you can't even view the web page, and you're just like, it's getting pretty annoying. Can't scroll on the page, you try to scroll and it freezes, and you're like, oh, shit. Fuck. So that's irritating. But that's not physics, really, entirely. It's a related subject. So yeah, I really have, I got to do the writing thing, and what else do I got to do? That's the important thing. And yeah, I still got it. I have been working on it. Just it is kind of interesting just to sit there and try to think of a way of aiming a photon. But I'm kind of convinced that the only way to aim one is to do it by pointing an electron. So if you can point electrons, then maybe you can aim some photons. But it seems like the only reasonable course. But of course, that gets a little complicated. But I should be able to handle it. Yeah. So what else? I mean, what they certainly should be able to aim are those, they say they've done the 2-slit experiment with carbon atoms, and certainly you should be able to aim those. So, but I have my doubts whether they have actually performed the 2-slit experiment. They've probably just done some kind of modification of it that they claim to be the same experiment, and it's really nothing like the real experiment. So that really won't work. Yeah, I guess they just cache so much stuff, the browsers. I think that's their failing. I mean, sometimes people are just too stupid to be given options, but it would be kind of nice if the browser gave you the option to say, don't cache this page, or don't cache the images on this page, don't cache the links on this page, something like that. So it wouldn't waste all this memory caching pages that you really don't want it to remember. Like, I'm not coming back here. Don't worry about it. Just forget I was ever here. Something simple like that, because it really does seem like, the browser just kind of kills itself by continuing to update pages you don't need it to update. I mean, there's certainly pages I want to keep running. I mean, I actually run my websites that way by, I have JavaScript running on pages in the background that update the website. And so I need a browser that does that. but it should be a function that you can turn on and off for each page. Just hit a little button and it just doesn't bother wasting memory maintaining that page. Well, you've brought up this EM drive before. There's, I'm trying to remember what the fuck it is. EM, what the hell does that stand for? It's a reactionless propulsive force. Well, there is no such thing. So, yeah, good luck, NASA, I would say. You're not going to undo the Newton reality of equal but opposite reaction. So that's impossible. And so, you want to tell me about NASA's perpetual energy machine or something, fine. But sorry, you can't do that. Well, whatever. NASA documents prove it. It's just such a, like I said, NASA doesn't have any credibility in science anymore. I mean, they have jumped the gun 4 times now or something on experiments and made claims that were completely exaggerations and nonsense. So whatever. Well, whatever. I'm jealous because I'm not as silly. I mean, these are space scientists and they don't really understand that it's kind of impossible to have a worm made out of insufficient material dimension to actually even contain something like chromosomes or DNA or any structure whatsoever. That you can't make a single-celled worm. You really can't. So, fuck you. Yeah, I mean, whatever. There's lots of nuclear energy to be exploited. I mean, there's no doubt about the fact that you can cause chain reactions that will allow matter to degrade. And like alchemy, you can take big atoms and turn them into small atoms and have lots of extra energy left over. And so that's certainly a possibility. But, it comes with the risk that, if you don't do it right, it'll blow your face off. Yeah, well, I'm sorry. I don't see how NASA's EM drive has anything to do with what I'm talking about. Well, again, they've made arguments about people have always this hype, right? So they claim that there was faster than light movement through nucleuses, and it turns out it wasn't faster than light; it was faster than light in a medium. So yes, the energy was moving faster than the speed of light through something like glass. Glass is 40% slower for light to get through. And they could change that number to 30% by having the electrons transmit the photons. And they would be transmitted in a straight line instead of going the crooked path. They would naturally travel through the glass. So it's a complete distortion to say something went faster than light. It didn't go faster than light in a vacuum. It went faster than light in glass. And these are important factual statements. And I'm just saying they exaggerate all this stuff, and it's just flatly irresponsible. Yeah, well, gravitons aren't. They're not outside of equal but opposite reaction either. So, for every right graviton, there's a left graviton, so to speak, in the universe. So if you collect a bunch of ones going right, it means there has to be a collection of ones going left somewhere. So you're still stuck with the same problem of you can't get it for free. You can't collect them for free. Like I said, you can release them from matter. Matter is just it's got, matter is batteries in a sense, so it's got lots of energy in it, but it's just the kind of thing, like I said, where it's just kind of tricky to get the energy out of matter without getting too much energy. That's even annoying about physics. They're using these words now, like they have all these theories that deny the existence of these photons, these these mechanical entities causing force, and yet they're starting to use words like magneton, graviton. Um, there's their denials are just seem quite empty when they start to create the very mechanical thing they say doesn't exist. All right, I don't understand how gravity works. How does mass feel each other? The gravity field explains it, but what is it made of? Well, that's the thing. It's made of light, so to speak, that you don't see. So the universe is full of intense light, an intense radiation, these gravitons. They're photons without a frequency. They're magnetism without polarization. So the entire universe is full of them all the time. There's an equal number of them inside my matter as there is outside of them. They all move in a straight line forever in whatever direction they're going, and they all intersect every point in space in an equal amount. And I'm just saying, if you create a field like that, then any two bodies you put in that field will be forced together because they will shadow each other from the force, because the force is straight line force. So if you think of it as a straight line force, it's just like light. Light creates a shadow. I put something in front of the light, the shadow is cast on me. The proportion of the shadow would mean there's more energy hitting me from behind than there is hitting me in front, and I'll move towards the thing that's shadowing me. So whatever side of me has more shadow cast on it is the side I will move in that direction. It'll create an imbalance, and I will move in that, I will gravitate in that direction. And the more I gravitate in a direction, the more I absorb stuff hitting me from behind, hitting me from the direction I'm moving. And so then I'll start creating a darker shadow on the other thing. And the darker shadow will make it move towards me. And it'll be a feedback mechanism. The two things will move towards each other. In the case of the Earth and the sun is insanely bigger than the Earth. And so we don't see the sun move, because the only thing that moves inside of the sun is its center of gravity changes. But the sun doesn't actually move a substantial distance towards the Earth. But its center of gravity gets tugged and pulled to a new location. And that's what causes the whole thing with Mercury and all that crap. Because Newton's math didn't account for the sun being moved. But that's the truth of it. But what point did I want to get to? But the real trick is what's different between my matter and the stuff outside of me and the space outside of that is just polarization. So when something comes through me, the gravity moves through me. If it's of a specific polarization, it'll affect my matter. If it's not of that polarization, it just moves straight through me. So the only thing that can accelerate me is specific polarization that's the same as the makeup of the material. And so the protons are affected by one kind of polarization, let's say up and down, and the electrons are affected by the opposite polarization. So in a sense, you're guaranteed to be moved by gravity because one of those polarizations is likely to hit you. And but most of the gravity goes right through you. It's only a small percentage of the field energy that is of the right polarization. Now, if I explode a nuclear bomb, it's the same force in a sense. I'm releasing a bunch of these little tons, but I'm releasing them with polarization that is substantially made out of protons and electrons. Most of the energy I'm releasing is the energy that was in protons and electrons, the quanta. So the gravity I release when I explode a nuclear bomb is highly dense. It has a lot of this in it. So when it hits something material, that energy is full of the polarization I'm sensitive to. So instead of going right through me and not bothering me, it's going to tear me to pieces. Yeah, so that's the short answer. Yeah. But that's sort of the irony, is that there's no change in momentum for any of the quanta. They just go in straight lines and they never alter. And the only thing that changes is the polarization. So they hit each other and the blue goes this way and the black goes that way. So it's just the color that changes. So the fact that there's something going this way stays the same. The fact that there's something going this way stays the same. The only thing that changes is polarization, what color it is, which is an interesting fact, is that although we see ourselves as being independent and some sort of different structure, we're exactly the same density as every other. If I could just grab a ball of space here, and maybe grab a ball of space here and grab a ball of space anywhere, no matter how dense it seems, there's exactly the same amount of quanta in each one of those clumps of space. It's just that some of the clumps have a lot of this blue, and some of the clumps have a lot of black, and some of the clumps don't have any blue or black, but they have some other color, red. And the red's invisible to us. It's intangible to us. But that's sort of an interesting truth that I have discovered about the nature of the universe. That we're just a pattern. We're not really made of extra matter or different matter. Well, it's different, but I just mean it's fundamentally just cue balls. They're just different colors. And the colors end up trapped. Once they're in a collection, they can't get out of the collection because they keep reflecting. So when black hits blue, blue goes this way, black goes this way. So blue, theoretically, if there was a lot of black coming in, blue could never get out, because no matter which way it goes, it ends up hitting another black. So no matter which way it goes, it just keeps hitting another black. It just gets trapped inside the pressure. So I would argue that the size of the electron is a description of how dense the field energy is. The size of the electron tells you how big the universe's pressure is, how dense the pressure is. The electrons held together by the exactness of the pressure. There's an equal number of blues inside the electron as there is potentially reflective elements on the exterior. So there's just as many lines trying to get out inside the electron as there are lines of energy coming in to the electron. So the pressure inside is completely balanced to the pressure outside. And that's why electrons are a certain size, and that's it. They're not bigger, they're not smaller. They're that size, because that's the only size they can survive at. If they're a little thicker, if they have a little more in them, then they would shoot out, they would get free. And if they had less, they'd get compressed. And now I don't see why they couldn't be compressed. I guess I'd have to think about that for a minute. I guess the pressure would eventually separate them, because they would all end up bouncing such a small amount that anytime there was movement, they wouldn't be able to exchange the movement, and so that the stuff going this way would end up going out, and the stuff going this way would end up going whatever way it was going, and it wouldn't be held together anymore. The pieces would separate because there wouldn't be enough internal exchange inside the electron. Yeah, I think that's an adequate explanation. See, the point is the electron has 3 different motions, well, at least 2 dimensions. And so when it moves, it has to update this dimension. So the stuff going this way, if it starts to go this way, it has to update this to move with it. So it has internal interactions that move this up, and then then it moves back sideways, and it moves it up, moves it back sideways, moves it up, moves it back sideways. So it has to keep updating the stuff going this way. So as this tries to go forward, it has to slow down and take time in terms of doing this. It's, I know this looks, it's doing this. And while it's doing that, it has to intersect the stuff doing this and push it as it's going up. So that's why this can't just zoom ahead. It has to update the stuff going this way. Some of you might have gotten that. Yeah, really, you'd really have to put all the little pieces together. And I mean, if I do this in the right order, I should be able to do it in an hour or 2, top to bottom. But there's a lot of little subtleties to all this shit. I mean, the big picture stuff of just pointing out the idea of the gravity being the only force, and that light is just a manifestation, in the sense that that's gravity that now has a specific frequency between tons of the right polarization. So there could be 3 tons all moving. Let's say they're all moving the same way. But the point would be is that there would be blue ones at very specific time intervals. So every 17th ton there would be a blue one. And we would recognize the blue ones at a specific distance as now being a photon. But it's really just gravity. It's this gravity now that has a pattern built into it. And so it's recognizable. And then magnetism would be without the frequency, but it's got the polarization. Yeah. Yeah, I think it's not a terrible explanation. So anyway, I just really wanted to say hi and just make a video, because I hadn't made one in a while, and just say, yeah, I am working on shit, and see if there's anybody that had something in particular, and respond in part anyway to the part of Hafadeh's video I didn't respond to. But again, it always comes down to him saying I have to prove them wrong, and I don't think they've proved themselves right. And I think that's the issue he should be also focusing on, is the evidence is poor, and it's certainly not good enough evidence for a conviction. I don't think they've in any way proved waves or proved Huygens or proved any of the mechanisms they're using to contrive consistency. And things like dark matter are a contrivance. And somebody left a comment about said something like, no one's arguing that matter is condensed in black holes. Okay, well, if you're not arguing that it's matter, then you have to argue, well, matter in the atoms. He said, yeah, atoms. Well, if they're not atoms, then they have to be the atomic parts. I mean, you have to get the mass from something. And so it seems pretty difficult to imagine electrons cooperating with, being able to compress electrons, because they don't like to be compressed, and protons aren't going to be compressible. Now, whether or not you can compress a neutron is the open question. They say there's such a thing as neutron stars, but they don't have any theory of how you compress neutrons either. I mean, obviously neutrons are pretty hostile towards each other, because the very fact that you can have the chain reaction that causes a nuclear bomb is a chain reaction caused by neutrons. I mean, you shoot a neutron into the atom, the neutron knocks 2 or 3 other neutrons out of the atom, and then those neutrons knock 2 or 3 neutrons out of the atom. I mean, clearly neutrons are, they don't sound like they're very compressible. They don't sound like they like each other much either. So the idea that you can compress neutrons and create high density and create a black hole, well, I'm just saying they don't have any evidence. We can't do that experimentally. We can't create a neutronium, like the way let's see them create a blob of neutronium. Let me see them create this heavy atomic substance. So, I mean, until they do it, the theory that you can compress mass into this small volume, see, I'm going to argue it's impossible, just because of the theory that the volume is already there. We're already as compressed as we can be. Everything's already as highly compressed as it can be in terms of the quanta. You can't make the quanta compress. They're all doing the straight line thing, as I pointed out. There's no possibility for compression. So all you can do is collect polarization. And I would argue that the electron is already very tight polarization. But that's what's gravitationally relevant. So I guess the argument would be is that the electrons and the protons are the only thing that's gravitationally relevant. They're the only things gravity is affecting. So gravity is basically just a nuclear force. It's only making electrons and protons move. Neutrons probably also, but I don't have a model for a neutron yet. So it's just those nuclear bits that are affected. And so the argument would be is, can you place that much polarization in a confined space? And again, the theory would be that it would appear not, because the fact that you can't make the big electron sort of tells you that you can't consolidate polarization any more consolidated than it is inside of an electron. Well, I have to think about that. But anyway, I don't think they have a theoretical source for high density mass. I mean, low density mass. So small volume mass. I don't have a model for creating low volume, high mass. So that would be high density, right? Yeah, a high density object. And black holes are always made out of something that's not the size of regular atomic atoms. I mean, you can't compress regular atoms into this, all the atoms in the Earth, you can't compress them into the size of a grapefruit with any kind of model known. Certainly no machine that'll do that. And such. All right, well, I guess I will not belabor the whatever. And so, yes, I will try to get back to more concentrated effort. It's lots of stuff. I have a lot of stuff in my real life to take care of. And then, I've been doing the philosophy thing, and just too many, just got too many projects. And too few me's to do it. Can't can't concentrate time, and I can't find more time and all that crap. So many actions I can do in the time allotted, and I want to try to do more actions than the time allows. So, but anyway, until next time, and such, and so forth, and whatnot. So hopefully I'll be back in a couple of days with something new and interesting, or something old and interesting, or something interesting. Yeah, mostly. Yes. Yeah. Just looking at these related videos, all this Trump shit. Howard Stern reacts to Trump winning. Howard Stern is such a douchebag. He's probably for Trump. He's such an asshole. Well, I hope he gets what he deserves. But anyway, yes, till next time, and such, and so forth, and whatnot. Oh yes, Forever Films, have to make you a video. But yeah, I got not that much news. I'm just kind of I'm just I'm really not bad. I'm just not, I'm just, yeah. I'm trying to do too many things. I gotta stop doing that. Focus, such. So anyway, until next time. Thank you for those who show up, and I'll do better. Yeah, probably, maybe.